everyone, welcome to our WebAssembly programming tutorial. In this tutorial, I'm going to explain how to run your C++ code on the web using WebAssembly. WebAssembly is a new type of machine-like code that can run in modern web browsers. It's a low-level assembly-like language with a compact binary format that runs with near-native performance and support languages such as C and C++ and Rust with a compilation target so that they can run through a web browser. It is also designed to run along JavaScript, allowing both to work together. Using WebAssembly JavaScript APIs, you can load WebAssembly modules into a JavaScript app and share functionality between the two. This allows you to take advantage of WebAssembly's performance, power, and JavaScript flexibility, and all of this in the same app, even if you don't know how to write WebAssembly code. In this video, we are going to use an existing C++ project and interface with it using JavaScript so we can use the same project to run it on the web. We are going to compile our C++ code using a tool named mscripten. You can download this tool from the link below in the description. I already explained in a previous video a C++ project used for solving system of linear equations. So I'm going to work on this project. To compile it with mscripten and interface with JavaScript so it can run on the web. Although this seems to be very promising, but until now it's just experimental and the documentation is still not powerful enough. But today you're going to see a real example of how you can use an existing project on to WebAssembly and run it on the web. So let's start. First, we're going to open our C++ file. We need to do some changes on this C++ file so we can compile it using the mscripten tool and interface with it using JavaScript and run it on the web. First of all, we need to include mscripten.h, which is the library of the compiler, and then here in our code we're going to add a function written in C++ to take the equations as a string, then parse each equation and get the solution for the system of linear equations and return it back to the JavaScript, and the JavaScript view the result to the user on the screen. So we come here and create extern C. We are doing this for the compilation to understand or to know the place of the function, and also add this tag mscripten keep alive, and we add our function. It's a void function, pass equations, and the argument of this function will be a character pointer equan. We can't use strings because the JavaScript doesn't understand the string in C++ file. So to use a type which both can understand, we're going to use a character pointer instead of a string. First of all, we need to convert this character pointer passed to the function into a string, then do our work on it. So first, we'll create a new string, equan text, and pass to it the character pointer. So now this character pointer is converted to string, and this string is added to the variable equan text. Now we are going to split the string using the semicolon character, which separates between the equations. So suppose that the format of this string is as follows. For example, the first equation, 2x plus 3y minus 7z is equal to 9, and then a semicolon, and then the second equation, a semicolon, the third equation, a semicolon. So we're going to split on the semicolon character to get each equation. We're going to do our work which we already explained in the video, which we explained how to develop this project. Parse this equation, find the result, and return it back to the JavaScript file. So first, we are going to declare a new vector of strings in which we will add our equations after splitting the main string. Equation text. And we'll do a while loop, while true. We want first to get the index of the first semicolon character in this string. So int separator index is equal to equiantext dot find semicolon, and then we'll check if this separator index is not equal to -1, which means he found this character. Then we have the index of the first semicolon. So now we know the starting index of the first equation and the end index of the first equation. So what we're going to do is to push back into the vector equation text. Equiantext dot substring from 0 till the separator index. And then by taking the substring from 0 to the separator index, we have our first equation added to the vector. But we need to add the rest of the string back to this equiantext. So in the second iteration, we're going to find the index of the second semicolon, not the first. For example, if I have, this is my string, as I said, 2x plus 3y minus 7z is equal to 9. And I have 3 equations. So now, at the first iteration, I know the index of this semicolon. So the starting index of this equation is 0, and the separator index. So now I will add this to the vector, then I will remove it from the string. When we work on this in the second iteration, this will be the index of our first semicolon, and the starting index of the second equation will be 0, and the ending index will be this separator index. So I'm going to do the same thing after we add the second equation. We will also remove this from the string, and the last iteration of the third equation will do the same thing. So this is how are we going to split the string. So here we're going to say equiantext is equal to equiantext dot substring from separator index plus 1 until the end. And else, if the separator index is equal to -1, which means that he don't find he doesn't find this character in the string, so we'll just break out of the loop. And now we have a vector which contains our equation. We're going to iterate on this vector. So for int I is equal to 0 and I is less than equation text dot size and I plus plus. Okay, here's our for loop. We'll create a new instance from the equation class and pass to it the equation string, and then add the object to the equations vector, which is a vector of type its type is the equation class. We previously explained this also in the previous video, so if you don't understand, just check the previous video to understand this. So here we say equations, the pushback, equations, equation, and pass to it equation text of I, which is our first string. Then we have this. When we create a new instance from the equation class, it will do all the parsing work on this equation, and it will return them back into different vectors, a coefficient vector and a result vector. So first we will display, we're going to use the same method we used in the main function, which we previously explained. So we're going to use the same method. We'll just change this display equation and this cout are optional. We just do them to test and debug our project, but this won't appear for the user. It will just appear in the developer mode. So we can do this to test and develop and debug your program, fix any issue you are facing. So we have here the coefficient matrix determinant and the variable determinant. I'm gonna push back here the values of each variable determinant, and then here we are going to form a string which we will add in it the result and return it back to the JavaScript file. And we will iterate on the variable determinant, and we'll add to this results str plus equal unknown of j plus equal. We'll just need to convert this into int. Let's name it result int. And here int result int is equal to int and this value, and here we'll convert this int into string using string, and we'll add a semicolon between the value of each unknown. Then after we formed the string which contains the results, we need to pass it back to the JavaScript code. So we are going to pass it to a function named solution panel, which we will later on write in the JavaScript code. So we're going to here string script. This is this JavaScript script which we are going to run, and solution panel, and pass to it results str. We just need to convert this string script into character pointer so we can pass it to the JavaScript, and constant char s char is equal to script .c str, and then we will call the function mscripten run script and pass it our script. It will run it in the JavaScript side. So now we finished the changes in the C++ file. We'll just need now to create an index file and add in it our JavaScript code, and then compile, and everything will work. So we're going to create a new file, index.html, and in this index we'll add HTML head and the body, and we need a script tag. Actually, we need two script tags. The first one is the created file using the mscripten tool, which I will show it to you later on. And the second tag will add in it our JavaScript code, but we'll just here need to add a new div, which will be our main div id equal to main, and here's our div. Now let's write our JavaScript file. We need to do a simple user interface so that the user can input first the number of equations, then input each equation, press go, and then the JavaScript file send the equations to the C++ file, solve it, and expect the return value will be the result. So first of all, the first thing is to be done. We'll add var result and var equivalence and var pass equations, which is the function that we call the C++ function. And then we are going to create a new div. Var div is equal to document dot create element type div and div dot style. We're going to use just a simple and basic JavaScript code. We just need to add a simple user interface and see how are we going to interface with the C++ file and run this on the browser. And here we position absolute so that we can define the top and the left. Top is 5 and left is 5 pixels. And then the width will be 30% from its main div, and the height will be 50% from its main div, and the background color will be white. And document dot query selector main dot event child dv. So now we created a new div and we appended this div to our main div, which we initialized here. Then we will add an input so that the user can add and it the number of equations. So number of equations is equal to document dot create element of type input and number of equations dot style dot css text is equal to actually we're gonna use the same. Let's copy and paste this. Position absolute and the top will be 15 and left will be 25 and the height will be 20 pixels and the width 190 pixels. I'll remove this background color. This is an input. And append this to the main div, but before we do this we need to add a placeholder. The placeholder is equal to number of equations. This placeholder so that the user understands what he will write in this input. And we're going to add an event listener on this input. So when the user add the number of equation and press enter, we need to take this number and view number of inputs equal to the number he already written in the input. If for example, if he written 3, then we'll and press enter, then we will view for him a more 3 text boxes he will to write in it the equations. So key up and function event if the event dot key code is equal to 13, which means that the key he pressed is enter. So in this case, we will create a new div to add in it our equations. And the style of this equation div dot style dot css text is equal to, let's take this copy. Okay, the top will be 15% from its main div, and the left will be 8% from its main div, and the width will be 85% from its main div, and height is 80, and the background color is equal to white. Div child equation div, and also add a go button. Go is equal to document the create element div, and go with style.css text, we also have the position absolute, and this is a button, so the cursor pointer, and we need to add a border radius 2 pixels, and the background color midnight blue, and the color is white. Color is the color of the text, the background color is its color. Color is white, and the left will be 30% and the top will be 75%, and the font size will be 16 pixel. Okay, so here is our button, and go.inner text equal to go, and go.style text align is equal to center, and we'll add an event listener on this div on click. And when we click, we are going to check to iterate on the members of this div or the child of this div, which we will add on it our inputs or our text boxes, and take the value in each text box, form our string, pass it to the C++ file. Var j is equal to 0 and j is less than equi_div my child nodes net length and j++. We add our string on this equians, which we already declared here. So we say equians equal plus equal equidiv the child nodes of I dot value, and add a semicolon, which is our separator. And then when we have our string formed, we'll call function evaluate, which we will declare later on, which will call the C++ code and append the go button. Then we will iterate on the number of equians.value, which is the text box which the user supposed that he wrote in it the number of equations, to add our inputs. Number of I is less than number of equians dot value and I++. And var equian input is equal to document create element of type input. We're going to create an input for each iteration. Equine input style CSS text is equal to, we can take this, just change the values. So the same thing, position absolute, and the width here is 190. We'll make it 180, just a little bit smaller, and height is the same. Left is 15, and here for the top we need to declare a variable. So this top need to be changed at each input. So var c is equal to 25, which is the initial value of their top index, and c plus equal 25. We can just make this 15. This is fine. And we will after we finish the event listener of number of equations, we will append it to dv numbers of equations, and then we'll create a div for the solution. Document.create element of type div, and solution style css text is equal to let's take this position absolute, and the top is 0 or 5, and left is 30%, and the width will be 10% from its parent div, and the height will be 50% from its parent div, and the background color will be midnight blue. This is the div where we will view the result to the user. We will add this div and we'll append it into our main div. And we can just add a title, a string on the top of the div, which is its text is solution. Let the user understand this is the div where the solution will be viewed. And document create element type div title cs.style css text is equal to also position absolute, width is 25% from its parent div, and height is 25 pixels, and the background color is we can just make it transparent. So if we later on change the color of this div, and the color, which is the color of the string or the text written in it, will be white, and its top will be 10 and left will be 10 pixels and 10 pixels. And solution dot append child title. Then we will add our evaluate function, which will call the C++ code. And in this evaluate function, we first need to convert the string equiends into a buffer, so we can pass it to the C++ file as a character pointer. So to do this, var buffer is equal to module memory allocation equiends.length plus 1. Okay, and then module dot write string to memory equiends buffer, and then result is equal, or we can just, instead of this, we can just say module dot call. Here pass the name of the C++ function, pass equations, and here we'll pass the return type. It's a void function, so the return type is null, and the argument type is number, and the passed argument. Okay, here's it, our evaluate function. The last thing we need to add is the function solution panel, which we will call from the C, which we already written in the C++ code, which we will call to and pass to it the result to view it on the screen. So solution panel, and it takes result txt. We will split on this string result txt on also the character semicolon, which separates between each result, and then take the value of each string and add it to the div solution and output this on the screen. So first var result, I can just, it's already initialized, result is equal to dot split on the character semicolon, and var solution div is equal to document. We here, to get this div to append on it, we will add solution.id is equal to solution, and here document get element by ID and pass to it solution. So now we have the div which we will add on the result, and for var I is equal to 0 and I is less than result dot length and I plus plus, and for each solution we'll create a new div var we can variable div is equal to document dot create element div and variable div dot style dot css text is equal to, we can just take this copy the position absolute and top. We also need to do the same thing with the C, and here var C is equal to 25, which is the starting index or the starting value for the top index. So top is equal to C and left is equal to 10 pixels. Okay, and the width 85% and height 20. Translate and the color is equal to white. So okay, now everything is fine. And variable div dot inner text is equal to result of I. This is the value of the result. And solution div dot append the child variable div and C plus equal 25 to get the top index of the next div. So now we finished our JavaScript code. This is just a basic interface for our program. You can do whatever the interface is, and you can work on whatever the project is. I'm just using or working on my case, and you can use the techniques of interfacing between the two files to do this on your projects. Now let's compile our project. We're going to compile it using the mscripting tool, which I previously talked about in the beginning of the video. When you download the tool, this file will be downloaded. You will open this and run as administrator. And first you need to activate the tool. So we're going to work on this folder, emsdk activate latest. Okay, it's activated. Then we'll get our folder, the folder where the project exists. Okay, and give our command line. and extra exported runtime methods is equal to call and write string to memory and press enter. So now our project is being compiled. We'll wait for a few seconds. It just takes some time when you first compile the project, but after that the compilation wouldn't take that long. It would only take a few seconds. So compilation is finished. The last thing we're going to do is we add a virtual directory, the WIS, clear sites, and add a virtual directory, WebAssembly, and the physical path will be the okay, and here we'll add this web.config file. The browser needs this file to understand so he can run the .wasm file. Finally, let's browse this. So here it is, x plus 2y plus 3z equal to -5, 3x plus y minus 3z equal to 4, -3x plus 4y plus 7z is equal to -7, and press go. Here's the result or the solution for this system of linear equation. So now we finished. We developed our first WebAssembly project using an existing C++ file, and as you see, everything went smooth and easy. You can try this on any C++ project you have, or you can work on any other languages which the WebAssembly support, like C or Rust. Thank you very much for watching. See you in the next videos.